x would be something like that, and 4, and it would just keep getting steeper and steeper. Okay? Now, this next one, D, is different than these next three. It's going to be linear, it's going to look like a line, but it's going to change differently, and let's see if you can guess. So, you look at, let's just look at it without the plus 3. It's just y equals x, right? So how steep should it be? What's the grade of it? Right, it's just 1. We call that the slope. We call this coefficient, this 2 and this 1 and this 1/2. We call that the slope. So just like I said, the grade when you go mountain climbing or hiking. The grade is the slope. It's how steep the hill is or how steep the graph is. Okay, so we call that the slope. Now here, the slope is the same as it was up here, right? It's just going to be 1, so that we know how high, we know how steep our hill is. But now I guess I'll make an analogy that may or may not make sense. But you can call this 3. We call this the y. I don't want to call it, well, we call it the y-intercept. But I like to think of it, it's like the altitude. So say you're climbing, I don't know, you're climbing the hill at the end of your block, right? It may have the same slope as another hill. It may have the same slope as Mount Everest if you have a very steep block, right? But Mount Everest is much, much taller. It's much higher. So, for example, your block may be at sea level or just above sea level, 100 feet above sea level. Everest is, thousands of feet above sea level. So while it may have the same grade, it's way, way higher. So I'm gonna try to draw that real quick. I don't know if this will make any sense, but it might help. So we'll call this sea level, right? We know when we go hiking, everything's about sea level. Altitude's always about sea level. So if your block is here, right, your block's pretty steep, right? It's a steep hill, but it's pretty much at sea level. Now, if I take Mount Everest, right, it's way up here. I don't know if you can even see that. All right, so they have the same slope, same grade, but one's much, much higher. See that? Does that make sense? Above sea level, it's much higher above sea level. So we call it the y-intercept. Like I said, that may or may not help you at all, but it's just something that helped me remember it. So now we're back here. Same slope, but we've got this 3 to deal with, and I'll show you how that affects it. So come over here, we've got D. And that one is y is equal to x plus 3. Okay, and we're going to do our little t table. X and y. Alright, so we're going to do the same thing. 0, 1, 2, and 3. And we're just going to sub them in, right? So when x is 0, y is equal to 0 plus 3. So now y is 3, which that's interesting because it's been, every time 0 has just been 0, right? So that's interesting. So we'll see what that looks like. Same thing here. Y is equal, x is equal to 1. 1 plus 3 is 4. Okay, 2 plus 3 is 5. 3 plus 3 is 6. Okay, interesting. So now let's come over here. So when x is equal to 0, y is equal to 3. It's interesting. 2, 3. Okay, 0, 3. Okay, we'll see. We'll keep going. 1, alright, is equal to 4. 1, 2, 3, 4. It's all the way up here. Okay, that doesn't start to make sense yet. 2 is going to be 5. 2 is going to go to 5. And now our last one, 3, is going to go to 6. So 3 is going all the way to 6. Okay, so now we can draw our line, right? And don't get it confused. Maybe I should move this one. Our 2x, just so it's not confused. Y is equal to 2x. But now we've got this line here that's doing this thing. Okay. Now if you look at it, if I were to get rid of all these, I don't want to, but if you look at, this is our x plus, sorry, this is our y is equal to x plus 3. If you look at this line, okay, and you look at this line, okay, you see they have the same slope, they have the same angle, same grade. If you were climbing them, climbing the mountain, they would have an equal slope, be the same difficulty, right? In terms of the steepness. The difference is this one is moved up by 3. So this one started at 0, right? You started from base level. This one started though higher. It's like you started at altitude. So what we call this a translation, or yeah, I guess a translation. You basically just moved it up, right? So this is x minus 3. It would have just gone down 3. You would have started here. You would have started below sea level, all right? That's really all that's happening. It changes the y-intercept. And the y-intercept is just a fancy word for saying where you cross the y-axis. So here's the y-axis, right here. Remember, this is the x-axis. This number just tells you where you cross. This is called slope-intercept form. This tells you where you cross the y-intercept. This tells you your slope. This tells you where you cross. That's why it's got that name, slope-intercept. So if you get something that's in slope-intercept form like this, it's really easy to graph because you already know the slope of it, right? It's either 1, 2, 1/2, 1, right? And you know the y-intercept. Because like I said up here, where you can add the 0, the y-intercept, even though it's not written, it's just plus 0, plus 0, plus 0. Well, this one's got 1. So the y-intercept ended up being, for A, remember, the y-intercept, it's over here. For A, the y-intercept was 0. For B, the y-intercept was 0. C, it was 0. For D, it was 3. Right? So that one's not too bad. It's just, once you kind of recognize it and get familiar with it, it'll make a whole lot more sense, I promise. And if you practice it, you'll start to be able to see them, and you'll see one, and you just know it's a line because you know it's to the power 1, and you can start to see the y-intercept, and you could just draw it kind of almost from memory. You don't even need to do these tables, but the tables always help if you don't know what it looks like and you need to just figure it out. Just always draw the table, plot some points, and it'll start to come together and look like something. Alright? So that's 4. And now I know you said parabolas, which was something that was priority. So we're going to do the same approach with parabolas. Okay? Same breakdown. So 5. A. Y is equal to x squared. B. X minus 3 squared. C. Y is equal to x squared plus 2. D, y is equal to x plus 2 squared plus 3. Alright. So, y is equal to x squared. This is the baseline. This is how we're going to start off. And actually, I'm going to add another a in here. Or, I guess it'll be e. And it'll just be y is equal to 2x squared, just because I want you to see what those look like. And I guess we'll do an f too, just y is equal to x squared over 2, okay? Just to see. And we'll do a, e, and f all on the same graph, just so that you can see what they look like, alright? So, same concept, x, y. We'll put our notches in just to help us get the right scale. And, obviously I'm not measuring these out, so they kind of look kind of busted. But anyway, alright. Y is equal to x squared. It's a quadratic, right? So we would expect it to not be linear, because we know linear ones are only to the 1 power, x to the 1, right? And you guys haven't seen cubics, but cubics have their own shape. X cubed, they have their own type shape. They kind of look like S's. And then x to the 4th, they kind of look like W's. But we're talking about parabolas. We're talking about x squared. Okay, so we can kind of guess what they look like. And they have certain properties that make them easy to work with. Right? And you'll see them as we start to work them out. So let's just do A. Let's do A really quickly. y is equal to x squared. And we're going to use the same type of table. Like I said, and as you get more practice, the table becomes less and less necessary. You just know. Like, I know what x squared looks like, just I've done it a million times. But for the purposes, we'll do it here. And actually, we're going to use a few different numbers, just so that it can make a little bit more sense. So let's go with -2, -1, 0, 1, and 2. Okay? So we'll sub them in. X squared, right? -2 squared is +4. Right? -1 squared is +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay? So we'll come over here. Right? We've got our 0, 0. So we'll plot him there. Come over to 1. There's our 0, 0. Come over to 1. 1, 1. Right? 2, 4. So 1, 2, 3, 4. Okay? -1, 1. -1, 1. And -2, 1, 2, 3, 4. Right? So -2, 4. And so now you can see, this is one of the things, is they're symmetrical. On both sides of your vertex, you'll see that you get symmetry. So when you draw this, this isn't linear. It's parabola. It's got kind of a weird looking shape. I don't really know how to describe it other than a parabola. But it's kind of round at the bottom. And it's going up, and it'll keep going forever. If we kept going, if we did 3, 9, you know, obviously 9 would be somewhere up here. So it gets sharper. You get to 4, 16, it's even steeper, right? So this is our y is equal to x squared. There's our parabola. Pretty easy, pretty simple once you know how to do the table, right? So now let's do our e. I kind of did these out of order. Let's do our e. Y is equal to 2x squared. X, y. Going back to our basis, and we'll do the same ones, like I said, -2, -1, 0, 1, and 2. And actually, some of these might be off the page, so we'll have to work with them there. But anyway, -2 squared, right, is 4. We already know that times 2 is 8. -1 squared is 1 times 2 is 2. And we just know 0 squared is 0 times 2 is going to be 0. And like I said, we know that these things are symmetrical. So we can just go ahead and say this is going to be 2, it's going to be 8. Right? Because of the symmetry. Because we know it has symmetry. But even if we plug them in, just so we don't skip steps, 1 squared is 1 times 2 is 2. So we got 2 squared is 4 times 2 is 8. So now we come over here and we can say we still are at 0, 0, right? We go to 1. We're going to go up to 2. We go, and I only did 1, 2, 3, 4, 5, 6, 7, and we'll just say, that 8 is right here. Okay? And you go over to 2, you got 1, 2, 3, 4, 5, 6, 7, 8, right? So it's much steeper. 1, 2, -1, 2, -2, 8. Right? Connect our dots, and this one gets kind of hard to draw. Much steeper. Much, much steeper. Okay. Y is equal to 2x squared. Alright, does that make sense? It's really just a matter of seeing the numbers and knowing how they change. So we talked about with our linear ones. Remember we said that this number in front, the coefficient, was called the slope. And I called it the grade sometimes, you know, if you're hiking, grade. With this, I guess it's how how steep is your cup. If you kind of call these a cup, right? This one kind of has a wider base. This one has a very skinny base. Okay. So it's a little bit different, but same basic concept. Now you come here, and remember we can call this same as you know, x squared, times 1/2, or 0.5 times x squared. They're all the same. Sorry. Call this, x squared over 2, 1/2 x squared, or 0.5 x squared. It's all the same. And so remember, like we did last time, if it's more than 1, it was steeper, right? If it's less than 1, we expect it to be a little bit wider, which is what we're going to see. So we come over here, we do f. Y is equal to 0.5 x squared. And we will do our table. We'll do our table. And then we will say -2, -1, 0, 1, 2. -2 squared is 4 times 0.5 is 2. Right? -1 squared is 1 times 0.5 is 0.5. 0 is 0, right? Easy one. 0 squared times 0.5. 1 squared is 1 times 0.5 is 0.5. 2 squared is 4 times 0.5 is 2. So there's our symmetry again. Keeps coming back. We see it. It's always symmetrical about our vertex. And once you find your vertex and you find a few points, you can usually just graph it from that point. So, but we'll go ahead and graph it again. So we got 0, 0 right there again. 1 is going to be 0.5. It's kind of getting crowded again. 0.5. I'll try to get it in there. And the same thing on the other side. -1 is 0.5, right? 2 is 2. Right? Oh, sorry, you guys didn't even see that. So you got 0, 0, you've got 1.5, right? -1.5, 2, 2, 2, right? 1, 2, -2, 2. So now we've got something that's doing like this. Oh crap, I'm not seeing it. There we go, sorry. So we connect our dots like this. Alright, and we're going to connect our dots like this. Alright, and now if I had drawn this right, this would be symmetrical. And it's kind of symmetrical, but it's not all the way there. Alright, so you've got your y is equal to x squared is in here, right? You've got your 2x squared, which gives you your super sharp v. And then you've got your 0.5x squared, which is giving you this wider base, right? More U-shaped, okay? So that kind of shows you how these things change from y is equal to x squared to 2x squared to 0.5x squared. It lets you know how they adjust based on that coefficient in the front. So now we're going to knock out B, C, and D, and then that'll pretty much wrap it up. You should be an expert on parabolas by that point. So, come down here, right, because these ones are a little bit different. So we got B. And what did I say for that one? Y is equal to x minus 3 squared. Okay? Trying to think of how the best way to explain this. So basically, and we'll draw our coordinate system over here again. Yeah, we'll do that. So okay. All right. So we can do the same exact thing. We're gonna just go ahead and plot. And then I'll give you the shortcuts after. But you look here and you can say the same type of stuff. -2, -1, 0, 1, 2, whatever. and you go ahead and sub them in. So negative 2 minus 3 is 5, right? Negative 5. Negative 5 squared would be 25, okay? Negative 1 minus 3 is negative 4. Sorry, negative 1. Negative 1 minus 3 is negative 4. Squared is 16. 0 minus 3 squared is 9. 1 minus 3 squared is negative 2. Squared is 4. Okay? 2 minus 3 is negative 1 squared. It's 1. Alright? Now let's just keep doing this just for the sake of consistency. So 3 minus 3 is 0. Right? 0 squared is 0. 4. We'll do a couple. 4 minus 3 is 1. 1 squared is 1. 5 minus 3 is 2. 2 squared is 4. So you can see that we're starting to repeat. So we went from 25 to 16 to 9 to 4 to 1 to 0 to 1 to 4. If I did 6, what would you expect it to be? 9. Right? So 6 minus 3 is 3. Squared is 9. Okay? So our little drawing isn't going to do it much justice because we don't have enough space. Do we have enough space for 9? 1, 2, 3, 4, 5, 6. I'm going to move this line down. I'm going to move our x-axis down. Sorry, I have to turn it down a little bit. Okay. So we're going to just draw our coordinate system right here. Okay, now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got space for 9. Alright, so we go to 3. Let's just do 3 for just the sake of understanding, and then, like I said, I'll go back and explain it better. Alright, but we said 3 is 0. So 1, 2, 3 is 0. Alright. What about 4? 4 is 1. 4 is 1. And what was the other one? 2 was 1. Okay, so there's our 4, 1, 3, 0, 2, 1. 1 was equal to 4. So 1 was 1, 2, 3, 4. Boom. And then I think we said 5 was 4 as well. 5 is 1, 2, 3, 4. And then, 6, which is off the page right here, is 9, which is all the way up here. So we're going to come all the way up, so boom. So, and then our 0 is 9. Alright? So you see, we've got our same... Crap. Paper's moving now. Let me tuck this under here. Alright, boom. So we've got our same basic shape. Sorry, drawing this, looking through the camera is not the move. Boom. Got our same parabola shape. Alright. Now, the only difference that you want to note here is just like when we did the linear one, and I said there was a y-intercept change and it moved it and all that kind of stuff. This is the same parabola. It's the same exact thing. It has the same slope, same depth. The difference is it moved over, right? They used to be centered. They were centered all along here at 0. But we moved it over, okay? And that's just reflected right here. X minus 3. So when you think about, when we're talking about roots and how, one of these would equal 0. So this is equal to 0 at 3, right? 3 minus 3 is 0. 0 squared is 0. That's when you get your y is equal to 0. So that's where our vertex is, because all we did was just take a regular parabola, right, and move it over by 3. That's all it is. It's just over. So if I draw the rest of this, all I did was just move it over to the right. Okay? So you got this minus 3 here. That just tells you you're going to the right. Right? If it was x plus 3, it would have moved it to the left. by 3. Same thing would be like over here, like boom, and you know, whatever. Okay. All right. So that's B. That's what this looks like. Okay, it moves it over. And again, going back to this, if you just sub in, you never have to memorize what it looks like. Now, you want to, because you don't want to have to do this all the time. This takes time, it takes space. You don't always have time to figure all that out. But if you know what it looks like I said, I can look at y is equal to x squared, know exactly what that looks like, know exactly what 2x squared looks like, know exactly what half x squared looks like. So if you show me something like this, I can do it, you know, in 5 seconds. It takes me a second to draw the two lines and a second to draw the parabola. Same thing here, because I know this looks just like the other one, and I can just move it over. Now we're going to go over to C, and you'll see how C is pretty much just like what we did earlier with that whole Everest example I used didn't really work out well. Hold on. All right. So for C, y is equal to x squared. Y is equal to x squared plus 2. Alright, so here's our coordinate system again. You'll get good at drawing these after you do a couple of them. Alright, come back, same table, x and y. We'll do -2, -1, 0, 1, and 2. Okay? So you plug them in. -2 squared, right, is 4, plus 2 is 6. -1 squared is 1, plus 2 is 3. 0 squared is 0, plus 2 is 2. 1 squared is 1, plus 2 is 3. 2 squared is 4, plus 2 is 6. Alright, again, there's our symmetry. 6, 3, 2, 3, 6. We see that they have the same rough value. So now we come over here. 0 is 2. So 0 goes up to 2. Now it should start to look a little bit familiar, because the same thing is happening. We're just translating it up now. Remember, we translated it to the right, so it looked exactly the same from here. It was just over here. Now we're just moving it up, and we're going to end up making it look just like that. So now -1 is 3. 1, 2, 3. 1 is 3. Right? -2 is 6. -1, 2. 1, 2, 3, 4, 5, 6. We're up there. 2 and 6. Right? Makes sense? So come do one of those. And there's our same parabola. Alright. X squared plus 2. There's our same parabola, moved up by 2. So this thing here, remember I told you this number out in front is the slope. It gives us the depth, right? This second number is going to give us our altitude, right? If we want to call it that, altitude, right? Just tells you how much you're going to translate it up. So we moved it up by 2. If we wanted to move it down by 2, it would just be x squared minus 2. It would do the same thing. It would just be, instead of starting at 0, we'd be down here at -2, and it would kind of do that, right? So that's what that's do, right? So you can see, let's go back here, putting a number in here, inside the squared, x minus 3, that moved it left and right, right? Putting a number outside moved it up and down. Okay? Makes sense? So now, D, I don't even know where I put it. There it is. Sorry. D y is equal to x plus 2 squared plus 3, which is a combination of the two. So what would you expect to happen? And I'm just going to make this as big as possible because I didn't work this out ahead of time, so I don't know exactly where it's going to land. I want to make sure we have enough space to make it work. So, you know, we start to draw this and start trying to figure out what it's going to look like. You should be able to guess what, you know, what's going to happen, where it's going to go. Okay? So, what would we, let's start with the slope. What would we expect the slope to look like? Is it going to be a normal one like we had? Where is it now? I've done so many pages. Is it going to be a normal one? Remember this one in the middle? Is it going to be extra steep like this one? Is it going to be extra flat like this one? Right, now let's go back to it. Right, it's going to be regular. It's going to be a regular slope because we didn't put anything in front of the x squared. Right, because remember, that's how we changed that. The 2 here in front of the x squared is what makes it extra steep. The 0.5 is what makes it extra flat. It's just a regular x squared, so it's not going to change that way. But what about this? This is inside. What would we expect to happen there? Here's a hint. We've got one just like it, right? And what happened? It moved to the right. It was -3. It moved to the right. Okay? This one is +2. So what's it going to do? Move to the left. Right? By how much? So this one was -3. It moved 3 to the right. -3, moved 3 to the right. This one is +2. So it's going to move 2 to the left. Right? So now what you can do is just kind of do this. Just go ahead and move 2 over. Right? And just draw a new line here. And that just lets you know this is going to be the middle. Right? This is going to be, because we know this thing is symmetrical, right? There's a line that goes up here. If you fold it in half, it's the same on both sides. Same thing here. You fold those in half, they're the same. Okay? Fold that one here. It's the same. So now, we can come here and say, alright, well, we know on both sides of this thing is going to be the same. If we fold it over, it's going to be the same. And then you've just got this +3 here, which tells you you're going to actually, let's mix it up. Let's mix it up. Let's make this a -3 just because we had a plus something before. We had a, what was it? We had a +2 up there. So let's just make this a -3. Alright, so what happened here? We had a +2. We ended up going 2 up, right? Now we've got a -3. So which way are we going to go? Down. Exactly. By how many? +2, go up 2. -3, go down 3. So now same thing. You come over here and go 1, 2, 3 down, and then just draw a line like that. That'll just let you know that that's where you're gonna. This is gonna be your base of operations. Okay, and I can tell you right now, this is gonna be our vertex. This is gonna be our lowest point. Okay, but we can come over here. We're gonna go back to our handy dandy table. X and Y. Okay. Same thing. Now, because we know where the middle is, we know the middle is around -2. I'm going to start at -4, -3, -2, -1, 0, 1, 2, 3, 4. Just for the sake of showing all of it. All right. So now let's sub in -4. -4 plus 2 is -2. Squared is 4. 4 minus 3 is 1. Okay, -3 plus 2 is -1. -1 squared is 1. 1 minus 3 is -2. -2. -2 plus 2 is 0. Okay, hold on, this isn't making sense. Let me get this together in my head. negative 2. Oh, no, we're good. Sorry. Okay, got confused. Negative 2 plus 2 is 0. 0 squared is 0. Minus 3 is minus 3. Right? So let's do something like that. Negative 1 plus 2 is 1. 1 squared is 1. 1 minus 3 is negative 2. 0 plus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So there's our symmetry again. Remember, we said it would be symmetry about negative 2. That's why we came up here and did this thing. Alright? So we can keep going. These are going to get higher and higher. Right? I would expect this number to be bigger than 1. So 1 plus 2 is 3. Right? 1 plus 2 is 3. 3 squared is 9. 9 minus 3 is 6. And these numbers are going to start getting really big. 2 plus 2 is 4. 4 squared is 16. 16 minus 3 is 13. 3 plus 2 is 5. 5 squared is 25. 25 minus 3 is 22. 4 plus 2 is 6. 6 squared is 36. 36 minus 3 is 33. Alright, so obviously we're not going to do all these joints. These joints are huge. But here, this is the key. Right in here. Alright, so let's just go ahead and knock these out. There's negative 1, there's negative 2, negative 3, negative 4. Right? So negative 4 is 1. Negative 1, 2, 3, 4. It's going to be 1. Negative 3, negative 2. Negative 3, 1, 2. Right? We said negative 2 is negative 3, right? Negative 1, 2, 1, 2, 3. It's right where we said it would be. Right? Just by looking at it. Just by looking at these and saying, well, we know plus 2 means we're going 2 to the left. And we know that minus 3 means we're going